Welcome. So we're going to talk to you guys about network service mesh. So typically speaking, I like to run super interactive presentations. So please feel free to ask questions as we go through. If you have a question, it's almost certain that somebody else in the audience has that question, and probably a lot of them, so asking is good. I'm also going to ask you guys questions through the course of the talk, just to get a bearing of where you are and what's going on. And so, as any good scientist, the first step is calibration. So, real quick, how many of you can raise your hands? Excellent. Usually you get about 70% people. I don't know why there are so many people who can't raise their hands, but you guys are about 90-95%. This is good. Awesome. So real quick question, how many of you guys have heard of network service mesh? Oh, awesome. That's great news. And how many of you guys actually feel like you know something about network service mesh? Okay, good. We have lots of room to expand that. So Frederick and I are going to be presenting here, and let's go ahead and get rolling. Go ahead, Frederick.
Excellent. So welcome to our talk, and so we'll start with some housekeeping. So first, we have a network service mesh 2018 events page for KubeCon. So if you want to know what's going on from here on out, if that's network service mesh related, you can take a picture of this QR code, scan it, and it will take you to our events page. If you want the deck, it's also on the bottom left, so feel free to follow along.
We'll give everyone a second to take the pictures. By the way, tip for presenters, this is the most awesome thing ever to get people to take pictures of your slides.
Right, just waiting for the last couple people. Great, so let's go ahead and move on. So meet Sarah. So we have Sarah and the Secure Internet Connectivity, version 2.
Yep. So basically, humans like stories, so we're going to tell you a story. You think of it as a bedtime story with a little bit more package than normal. So meet Sarah. Sarah is writing a Kubernetes app that she wants to deploy in the public cloud, and one of her pods, not the whole cluster, one of her pods needs secure internet connectivity.
Cool. So from Sarah's point of view, this is what her needs look like. She has some L2 and L3 connections she wants to her corporate intranet, and she has her Kubernetes interface, and she wants some security there in her L2, L3 connection. And she still wants her normal Kubernetes networking.
Yep. So normal Kubernetes networking still works. Next slide is you've got this connection to her corporate intranet, and there is something called security that happens in there that she never wants to know about and doesn't really want to understand, but it's really important. Her InfoSec people tell her it is. So real quick, next slide. So yes, securely, for some definition of security. Quick question, how many of you who write applications actually want to know what's going on in that security bubble? Oh, interesting. That's a lot more than I would have expected. Most application developers want security, but they don't really want to know how it works.
I think we make secure network mesh later on. So.
There we go. Cool.
So this is Sarah's definition of hell. So she has all of these things that she has to take care of, starting with how to find out what subnet that network interface should connect to.
So, and okay, if you make her define a subnet, okay, what has to go in that subnet? How big does it have to be?
And okay, so you define a subnet. What if it's too small in the future?
Because we don't scale up our replicas ever.
Yeah, of course not. And then we have this interface we have to define as well. So who defines that? Does Sarah or someone else define it?
And then you got the problem of, now that this is all up and going, how does she actually get the corporate IPs as routes in her pod? Sarah's pod can't even add routes to the routing table. It's not privileged.
We can make it privileged and just throw all security out.
This is true. Not a good idea.
So we also need more replicas. The subnet's too small. So does that mean that Sarah has to redo all of this over again?
And if she redoes this all over again, now she has to go take all the interfaces from having built a new subnet and connect them all to that subnet again.
And maybe her routes too.
Indeed. And then, of course, if you don't talk to your enterprise networking guys, you may assign IPs that are actually valid IPs in your corporate intranet to that connection, and you don't want to do that because then things don't work properly.
Or you followed all of their rules, and you find out they re-IP'd anything anyway, so you have to do it anyway.
And now we start all over again.
So, and then they add a new seeder. So how do you update the routes? So remember that Saras Pod is also not privileged. Why, God, why?
That's the next slide. And then you've got the problem, like, security happens there, but what happens when someone decides, okay, security means now we've got a firewall pod that we want to stick in front of the VPN gateway pod. Now Sarah has to actually go through and do all of this again, only more complex. This is a terrible, terrible idea. And the real fundamental problem is, why are we doing cloud-native networking with 1990s networking concepts? It's 2018, people. Why?
So enter Ariadne, our friendly network service mesh spider.
Yep. So this is Ariadne, the friendly network service mesh spider. So what is network service mesh? Is that like Istio?
Well, it's sort of, all those amazing things you can do with Istio, well, with the TCP and HTTP connections, well, we can do that with IP and Ethernet and various other L2, L3 protocols.
Yep. So this is a really big distinction, and this is like the critical one for understanding how network service mesh differs from service mesh. And that is, service mesh does an amazing job of HTTP and TCP streams, and we don't do any of that. Because the Istio guys, the Envoy guys, they do it super well. Why would you need us to do that for you? But what NSM does do is the payloads that are L3 or L2 payloads. So if the payload is not a stream, it's IP packets or Ethernet frames, that network service mesh can do for you.
Yeah, and the term I've personally been using for talking about service mesh and the above one is actually closer to application service mesh, because it is very in tune with what your application is doing. So we're looking at the L7 and L4 layer. So we are looking at L2 and L3 in this scenario. So what does Sarah really want to do? She has a pod. She wants to connect it securely to her corporate intranet with some security.
So with network service mesh, this is actually described really simply. You have a custom resource in Kubernetes. It's called a network service, and it has a name, and it will tell you the payload that it takes, in this case, IP.
So this looks a lot like a service resource in Kubernetes. Is there any relationship?
Not quite. They're intended to look very similar, but where services in Kubernetes are fundamentally talking about streams, TCP, and datagrams, UDP, here we're talking about payloads that are IP or Ethernet.
So does that mean I can change it to something else, like maybe MPLS?
Yes. So while most people are going to care about our payloads that are IP or Ethernet, network service mesh was designed to handle more exotic things like MPLS or DOCSIS or any number of other funny protocols that most of you probably won't ever encounter, but there are people who care about them, and it turns out it's super cheap to actually take care of their needs too.
So is this all I need? I just use this and get a deployment for a VPN gateway pod?
Almost. So, and we'll talk about this in a little bit. There is an init container that you stick in your pod to wire these things up, but you don't really have to understand anything more than, I want a network service, and I would like it to show up in my pod.
So I don't have to worry about the interface or the subnets or routes. Like, how does all this work?
Yeah, so how many of you actually want to ever know about subnets again? And how many of you who want to know about subnets again are networking people as opposed to application people? That's what I thought. We got ringers in the audience. Yeah, typically interfaces and subnets are kind of a really bad idea to have to know about if you're an application author. You just want shit to work.
Okay, so we have three basic concepts. You've already been introduced to the first, the network service itself. So it is something that you send L2 or L3 payloads to, and it does something that you want.
No, and it's really important to realize with the network service, you're not necessarily talking about a network, right? Because typically what people care about is not, I am on this subnet. Again, see previous question about subnets. What most people care about is, can I connect to the things that I want, connectivity? Do I have security? Have I got the quality of service that I asked for? And some other kinds of things that are going to happen for them. So this is explicitly a network service, not necessarily a network, although it may come about that way.
So is the secure internet connectivity a network service?
Exactly. That's the example we're dealing with here. That's the network service. It's the abstract thing you want to connect to. Just like a service in Kubernetes is the abstract thing you want to connect to.
Okay, so the second concept that we have is a network service endpoint, and that is a pod in this scenario, or in this example, it is the pod that provides the network service that you want.
Yeah, so in this example, it would be, yeah, so it's very analogous to endpoints, and in this example, it would be a VPN gateway pod. Next slide. Yeah, so this would just be a pod that gives you VPN gateways. So it knows how to take the connection from you and open something like an IPsec tunnel back to your VPN concentrator. Cool.
Okay, so the third concept is the connection. That is the L2, L3, or L3 connection that gets you from your pod to your endpoint.
Yeah, and keep in mind, this is not a TCP connection. TCP connections carry streams of bytes. This is an L2, L3 connection. It carries IP packets or Ethernet packets or some other L2 or L3 payload.
So what does it have to do with an interface?
So it may happen to be as an implementation detail that this gets injected into Saras pod as an interface. In fact, for most application developers, that'll be the way it is. If you're doing something more sophisticated, like you're writing your own network service endpoint or your own cloud native network function, you might use something more exotic, like memIA for vhost user. Network service mesh is sophisticated enough that we can handle all of those eventualities without actually having to change anything that your consumers or providers are doing. So the VPN gateway pod may use memIF. Saras pod may use kernel interfaces. Neither of them have to know about the other one in terms of what it's using for a local mechanism. Yes?
What do these connections look like if Saras pod and the other pod live on different physical hosts?
So the question was, what does these connections look like if Saras pod and the other pod live on different physical hosts? We'll drill into detail on this shortly, but effectively what it ends up being is there is some kind of a tunnel mechanism that comes into play. And again, this is negotiated between whoever is handling the data plane on Saras node and the node where the network service endpoint is, such that it could be VXLAN, it could be SRv6, it could be something smart that someone comes up later. Sarah never knows, the network service endpoint never knows, and so things just work. Did that answer your question? You get to define the preference order of the encapsulations available from the things that are negotiating that. So, as the odd network guy, you definitely get to say, I would really rather use SRv6, but I can do VXLAN. But if the guy on the other end can only do VXLAN, you're doing VXLAN.
Okay, well, what about my subnets? How does that get defined?
So one of the central realizations we had with network service mesh is IPAM sucks. And part of the reason is we keep trying to do these crazy global IPAM schemes. And it turns out that the party in this picture who is most able to know what are valid IP addresses for the corporate internet to assign to Saras pod, and in the best shape to know, that kind of information is, in fact, the VPN gateway pod. And so the assignment of IP addresses is actually negotiated by network service mesh such that the network service endpoint can assign that IP address for the intranet on this connection to Saras pod. So it's handled peer-to-peer. So from Sarah's point of view, she doesn't see subnets, she doesn't do IPAM, she doesn't manage subnets. She just gets an IP address and shit works.
Okay, and what about routes? How does that all get handled?
So again, same realization. Who in this picture is most likely to have the proper understanding of what things should be routed to the corporate intranet? That's going to be your VPN gateway pod. And so your VPN gateway pod, as part of the same connection context that gets set up, in addition to providing Saras pod with an IP address, also provides the list of routes that should be routed to the corporate intranet, so that Sarah doesn't have to worry about that. If she's sending something to a corporate intranet IP, it goes over this connection. Yes?
Is that anticipated to be a singleton or more of a one-for-one mapping for each pod that needs that type of service?
So all the connections in this picture, so the question was, is that expected to be a single, what was the word?
A singleton, like a single instance of this VPN gateway.
Right, so the question was, do we expect the VPN gateway to be a single instance per consumer, or do we expect it to support multiple consumers? And the answer is embrace the healing power of and, which is to say that the network service endpoint, if it is decided that it is going to provide connectivity to multiple network service clients, can accept multiple incoming connections. If you have a case where your network service endpoint should only accept one incoming connection for whatever weird reason, that is also doable.
We'll
But-
say for security.
Yeah. But my expectation is that typically one VPN gateway pod will probably service multiple pods.
Great. So what about that firewall pod? IT just told me I need to have this firewall pod there. How do I get that in?
Yep. So this is actually, if we go on to the next slide, this actually is super easy to do. So how many folks have heard of virtual hosts or route rules in Istio? So we do something very much like that. Right? Except what we do is instead of having virtual hosts, our network service object can actually take some policy information to allow us to compose network service endpoints collaboratively to provide these network services. So when a network service endpoint advertises that it can provide a network service to NSM, it can put labels, key value pairs, on that advertisement. So we know the VPN gateway pod, when it says it provides secure internet connectivity, we know that it has got a label app equals VPN gateway. And we know that the firewall pod, when it says it provides secure internet connectivity, it has a label app equals firewall.
Okay, so effectively, when the pod requests the connection to a network service, it attaches labels to that request. And so those are what we call the source labels. So what we're doing in this scenario is we're saying that the firewall pod is asking for an L2 or L3 connection, and it would use the source label that it is a firewall. So that's what differentiates it between the Saras pod versus the firewall pod itself.
Yep. And so, moving on to the really exciting slide, we take the same definition we had for a network service before, and we add to it a list of matches. And in this case, we have a match that says it's got a source selector for app equals firewall. That source selector matches this connection request from the firewall pod because it has app equals firewall as its label. And then the result of that match is that we have a route that says destination and has a destination selection. That is app equals VPN gateway. And that is how we select which pod, which network service endpoint, to connect this request to. So the firewall pod offers secure internet connectivity, but it also consumes secure internet connectivity. And the really cool thing about this is, as I expand the number of things that I'm composing here, I never have to change anything about that firewall pod. It's dumb as a rock, which is really what you want.
So, quick question: if Sarah decides, like, if an update occurs, and does Sarah have to change anything if the network service itself changes?
No. Basically, if the network service changes and Sarah launches a new pod, she will get whatever policy is in the network service when she launches the new pod. So your NetOps people could decide that they need an IDS in here, or they want to do something super complicated where there's an Envoy proxy that's not part of your cluster service mesh, it's part of your corporate internet service mesh, and that it may go to one of two VPN gateways, one of which goes to LA and one of which goes to New York. All of this can happen without Sarah having to change a damn thing about her pod or her pod spec.
Cool. So what about the pod? How does my pod get to the firewall?
Yep. So again, this is where the magic of labels comes in. You have a match that doesn't have a selector. So that match is going to actually match anything that's coming in that's not carrying labels, which Sarah's pod won't. And its destination is going to have a label app equals firewall. So that connection comes in, we look at it, it matches the I don't have labels match. We connect it to something that is providing secure internet connectivity that has app equals firewall. And now we've got the composition here of two network service endpoints to provide a single network service that Sarah wants. And Sarah is none the wiser. She is in a position where she doesn't have to know what does the security and where it can change over time without her having to change.
Okay, so we just update the deployment and then update the network service mesh, and then we're good to go.
Exactly. So deploy the firewall pod, update the network service, and all the new pods that come up online from Sarah will get connected through this kind of composition.
Okay, so Sarah does not have to worry about her interface. Her IPs didn't get assigned or routed. She does not have to worry about the routes themselves or the interfaces that are on there. So that doesn't mean that they're not there, but they're implementation details that she doesn't need to pay attention to.
Exactly. Which namespaces? There are so many. So we're looking at things that could be done with Kubernetes namespaces around this, but it's not a necessary part of this. We have an entire slide talking about remote things.
Yeah.
We'll get to that. You're an excellent straight man, but you're a little early. Cool.
Okay, so do I need a modified or updated version of Kubernetes?
No, and neither do you need a magic CNI plugin. If you like your CNI plugin, you can keep your CNI plugin. Basically, network service mesh is completely orthogonal to the Kubernetes networking you know and love. The Kubernetes guys have done a super good job of that networking. We are not here to screw with it. So you get the Kubernetes networking interface. You keep getting exactly what you get there from your CNI plugin. We're happy with that. You're happy with that. And so it doesn't matter what CNI plugin you're using. Network service mesh doesn't use CNI.
Great, so how does that work?
Yep. Let's go ahead and skip ahead a bit. So on every pod, as a daemon set, you have an NSMD. This is the Network Service Manager daemon that runs on every pod. And there is some kind of a data plane that is running on your pod as well.
Okay, so the very first thing that happens in this scenario, we're using an init container, is there's a request connection. And the request connection says, I would like to connect to my secure intranet gateway.
And the important thing to realize about this is all done by a stock init container. You set an environment variable that says, I'd like to connect to secure internet connectivity. And that's it. Nothing has to change about Sarah's application.
She also specifies whether she wants a kernel interface or some other thing like vhost user or MIF.
And in the case of somebody like Sarah, you're always going to want a kernel interface. You're an app developer. But if you're writing a network service endpoint or a CNF, you can ask for more complicated things.
Okay, so we'll start off with the simple use case of, what happens when your VPN gateway pod is on the same node. So we get the request connection. The request connection gets forwarded to the VPN gateway pod, which then accepts or denies. And upon accepting, it includes information such as what IP addresses should be set up, what routes, and so on. It then creates and injects an interface into the VPN gateway pod, and then creates and injects the interface into Sarah's pod, and then tells Sarah, performs the cross-connect in the data plane, and then responds back to Sarah saying that you are good to go.
So this is a super important point. All connections in network service mesh are point-to-point. If you want a bridge domain is a network service. You can have one, we'll connect you to it, but that's something you're going to have as a network service.
The same goes with a subnet. If you want a subnet is also a network service.
Yep.
Okay, so what about NSMD service discovery and?
Yep. So this is a subtle difference with between network service mesh and service mesh. So if you're doing service mesh with something like Istio, you're doing service discovery, you're maybe doing some short circuiting and other things. But as it turns out, there is effectively one settled way to do stream of bytes, and that settled way is TCP. And there's a bunch of stuff in the kernel that does the connection setup for you. So we just use that. When you're talking about L2 and L3 connections, there are nearly infinite number of ways they could be set up. There are nearly infinite number of ways that you might actually negotiate setting them up. And so network service mesh does the setup of the connection for you as well, so that we have one clean way that it's done.
Okay, what if the VPN gateway pod is on a different node?
Yep, so in this case, it looks exactly the same to Sarah. Her pod, the init container in her pod comes up, it requests a connection to its local network service manager. That network service manager looks in the Kubernetes API server as the network service registry. It looks for network service endpoints that provide this, and it looks for the network service object in case there's some policy it has to take into consideration. And based on that, it can select what network service endpoint it's going to and figure out where its network service manager is, how to reach it as a URL. It then forwards a request connection to that network service manager, and in this case, you're negotiating your preference as to remote connections. So this message will contain a preference ordered list of, I would prefer SRv6, okay, I can also do VXLAN, and will include any kinds of constraints in those parameters. Like if I'm doing VXLAN, it would carry the source IP from my perspective. And then when it gets to NSMD2, it looks exactly the same to the VPN gateway pod as it did when they were on the same node. The NSMD sends a request to the VPN gateway pod, it gets a reply, it injects the interface, it creates it into the tunnel, and then it replies back to NSMD1 with the selected mechanism for the remote cross-connect, and precisely the parameters so that the first NSMD can inject the interface into Saras pod and build its into the tunnel. And at that point, you have a cross-connect. Yes?
Is it getting encapsulated inside the network service or in the virtual switch?
It's encapsulated in the data plane. Sarah doesn't know that this is VXLAN. She doesn't know that it's on a different node. It could be SRv6. It could be frickin' MPLS over UDP for all she cares. Yes?
What is the footprint of the Kubernetes API server?
Well, I mean, you've always got the Kubernetes API server in Kubernetes. We do have the ability to have different kinds of network service registries, but being KubeCon, we're mostly going to talk about doing it this way. Yes?
I'm another one of those sneaky network guys.
What is it with the sneaky network guys in the audience? Go on.
Sneakernet.
So I've got this one network, and I define kind of a meta service that when I connect to it, just instantiates policy and the end nodes to.
We have a slide for you later. What is it with the network service guys being early as straight men? You did it to me, you did it to me. We got the slide, it'll make you super happy. Cool, next up. Awesome, so this is super easy, and I think next we have demos. How are we doing on time?
It is 4:07.
It's gonna be tight. So we have 2 demos available to show you guys, actually. And I'll do a little show of hands just to see which one you'd like to see first, because we're tight on time. So, demo number 1. We will show you actually working in Kubernetes with a user interface that will show you what it looks like. Saras story. Saras pod to Firewall Pod that does transparent firewalling to VPN Gateway. The VPN Gateway is simulated because concentrators are hard, but you'll see it there. Or, demo number 2. In 6 minutes, Frederick will, on stage, live, code a working network service endpoint, deploy it to network service mesh, and show it working. So, real quick, how many people would like to see live coding of a network service endpoint? Okay. And how many people would prefer to see instead first the deployment of the VPN gateway use case to network service mesh? Okay. I think you're coding, Frederick.
Yeah, I'm coding, okay. I'm on the hot spot. So, well, step 1 is I just deploy network service mesh itself, so we can see that it is now running. So we actually have 2 nodes on this one. So you'll see the nodes, node 1 and node 2. And so that's why you see 2 NSMDs, 2 data planes.
And there are a couple extra pods there for Skydive, because that's what we do for the user interface for visualization.
And now that we have Skydive, it gets assigned a port, so we will grab that port so that we can see Skydive. So just change that port out, and we will see that there are 2 systems. And let's go ahead and expand it out so that way we can see what's going on. Okay, so now the fun part. So we're going to start with the network service endpoint. So this is off of an ICMP responder. So we're going to change this to be a bridge domain. So we're going to start by first renaming the network service to bridge domain. So that way we connect to the right one. And the second thing we're going to do is, so this particular service is actually what handles the network service itself. Like it's what's providing the network service ICMP now bridge domain connectivity. So what we're going to do is we're going to create a bridge domain, and we will create the bridge domain type, and within this, we'll call it Jeff, because I named my bridge is
Always a good name for bridge domains.
Because the NSM abides. And we'll just set up age of 120 for it.
Being a bridge domain, your learning ages out at some point.
And then what we will do is we will create a list of empty interfaces to start off with the bridge domain, because it's going to start off unpopulated.
We have no clients, so we have nothing connected to the bridge domain.
And then what we're going to do is we're going to add some state here. So this will be bridge domain, and then so we'll create the field. Ooh, there's a little bug here, so we'll catch that right now. So this should actually be a reference. So problem solved. Service create bridge domain. So this does not exist, so we will have to create this method. So the method now exists. And so what we will do then is we will create a function And this function will return an RPC data request and an error. And what we will do is we will run this function. So we'll run the function and we'll give it context of a background. So it'll run until it works or doesn't. And so what we're going to do on this one is we're going to create a new request. And this request, oops, too much, is going to have a bridge domain. And that bridge domain is going to have in it a L2, a list of bridge domains, which is going to have the one bridge domain inside of it. And so this is Perl. And then we will return request and nil, so there's no error. So this will create the bridge domain, but we still have to connect things to it. So the way we will connect things to it is we will go to our ICMP network service, and we have this create VPP interface that we're going to change to we're going to bend to our will. So we have this MEMIF interface that we're going to add. So this is a memory interface. So the data plane will actually use a memory interface to connect in. So what we need to do is we need to get the interface out first.
So the part of the code that's in here that we aren't changing basically takes the incoming request and it creates an interface that we're going to plug into the VPP, the data plane that is running inside this pod. So it just connects that up to there.
So we want to create a new, that looks like it's the wrong one. Bridge domain interface. Maybe it's the right one. Yep, that's the right one. And then what we will do is we will copy over the interface name, so that is how it knows which interface is being added, and we will delete the rest because we don't need to modify anything else. And then what we will do is we will append this to the bridge domain. And then we will add this to our data change. And with that, that should be enough. So let's make sure it compiles first. It takes about 7 seconds. And then what we will do is we will create a container that has the bridge domain inside of it.
And incidentally also save it onto the Vagrant Kubernetes cluster that we're running locally. Somebody has to be able to get the pods.
I think that happens in the deploy though. So.
Also true.
So then what we'll do is we now deploy the bridge domain. So we should see in here a new bridge domain should pop up in a few moments.
Was it bridge domain or bridge domain NSE?
Bridge
Nope.
domain NSE.
Okay, cool. Yeah.
One step at a time. So there we have a new bridge domain. And now start adding some clients to it. Actually, before we do that, to see how much time, I have 5 minutes. So I should show what this looks like. So what I'm going to apply is this is actually just an Alpine image and with an init container that tells it to connect to the bridge domain app. So I did this earlier since it's not as interesting, but it's interesting to see the app equal bridge domain. So.
Yep. You can see the environment variable where we say, okay, we want a network service named bridge domain. We want to connect it to an interface named NSM1. Because you might have an opinion about the name of the interface.
And then, so we will deploy the bridge domain NSC, and we will watch to see if anything comes up. Oh, there they are. So we have 4 of them. So just for reference, let's go ahead and get the deployments, and let's go and scale that. So let's say it's 5. Oops, I messed something up. Dash dash. And we should see a fifth one pop up. There it is.
So in each of these pods, each of these 5 pods is now connected to a bridge domain network service endpoint.
And we can look at information about them. So on the local system, these are 2 nodes. So on the local system, we can see the cross connect. The source is a kernel interface. The destination is a memory interface. And for the remote connection, also we see kernel interface connecting to a memory interface, but it's via a VXLAN with parameters that were auto-negotiated.
Yep. So, questions? Yes?
Last one, and then I'll shut up.
Sneaky network people.
So when I create these network service endpoints, which is its own pod with a network function, say I'm doing something that actually has like a route table or something where I actually care about the resources that were assigned to that pod, and I overtax those resources, do I do the Kubernetes method of scaling that up horizontally? If so, how does that work with the whole labels and the match system?
So you can scale it out horizontally. Effectively, you can treat it like you would scale out anything else horizontally. If you've got a web service and it's scaling out horizontally, you exceed capacity, you do some short-circuiting behavior, et cetera, et cetera. Here you can scale it out horizontally, so new clients are coming in, they get connected to a different instance of it. Now you can do super complicated things if you want to do, for example, a distributed bridge domain and have those distributed bridge domain pods, connected to each other. That's also doable. You could either do it within network service mesh, or you could do it with a different mechanism than what network service mesh provides you. We really don't care.
I also have a short thing on that to finish answering that question. So right now, most people, when they build VNFs, they create a VM and they scale it vertically and try to shove as many connections in as possible. We're going to have a paradigm shift to really leverage Kubernetes where we scale horizontally.
So real quick, last 2 slides, because then we got to get off stage because we're running
yes.
over. So last 2 slides real quickly, because and we'll have to talk about this afterwards. So having done the demos, we are actually building a create verb where you can dynamically create network service endpoints, for example, on a particular node. This should be super awesome if you're doing edge stuff. We don't have time to go into it a lot right now. The next one was something that both of you got to, you sneaky network people, which is that we don't much care that you could have things in the service registry that are pointing to network service managers that are in a different cluster, that are sitting in a Vim somewhere, or that are even fronting for actual physical hardware. We're totally cool with all that. And then finally, we've got some thank yous. We've had a lot of people on the network service mesh team who were super hard to get here. We had some nice help with Skydive integration from some folks at Orange. The Skydive team has been super helpful. We've had a lot of support from other people in the community.
And we have an announcement.
We do have an announcement. So one of the people who's listed here is Nikolai Nikolaev from VMware. Nikolai, are you in the audience? Cool. So stand up, Nikolai. Because we wanted to actually do this announcement publicly. You've done a huge amount of work, including most of the match service selector work and so forth. And so we wanted to take this opportunity to congratulate you on becoming an NSM committer. So if everyone can give Nikolai a big hand. We'll get those permissions set up right away. You should have code review requests shortly. Cool. And we're happy to talk to people afterwards. We have overstayed our welcome. We should get the hell off the stage.
And we're also going to do one last thing. We're going to both be around for like a happy hour.
Oh, that's true. So anyone who wants to wander with us, we're going to go find a table with anyone else who wants to talk about network service mesh between now and 5:15, doing an NSM happy hour. So meet us right outside. We'll go wandering.